This is the MiG-21, the most produced jet fighter in history and one of the longest-serving fighters ever built. Designed in the 1,950 seconds as a Mach 2 frontline interceptor, it became instantly recognizable by its circular nose intake and razor-sharp profile. The aircraft's iconic delta wings and raw agility made it a symbol of Soviet speed and efficiency. The MiG-21 embodied the Soviet approach to air combat: hit fast, strike hard, and vanish before the enemy could react. In this film, we're taking a deep dive into the MiG-21 F-13, the first major export variant and the first equipped with air-to-air missiles. We'll explore how this aircraft reshaped air combat tactics across 6 decades and dozens of conflicts. From Vietnam to the Middle East, the MiG-21 changed how nations fought in the sky. We'll take you inside the jet, from its cockpit to its engines, its weapons, and its combat doctrine. This is a machine built for raw speed and ruthless efficiency, a pure product of Cold War engineering. My name is Marcus Reed, and this is Iron Blueprint. The MiG-21 F-13's airframe was engineered with a single purpose: stay light, stay fast, and survive at Mach 2. The aircraft measured 44 feet, 1.9 inches in length, and stood 13 feet 5.4 inches tall, with an empty weight of 12,882 pounds. Its compact delta wings spanned 23 feet 5.7 inches and covered 247.6 square feet of surface area, stable at high speeds, agile during sudden breakaway maneuvers. Compared to the American F-4D Phantom II, which stretched more than 58 feet and weighed nearly 29,000 pounds empty, the MiG-21 was tiny, and intentionally so. A smaller aircraft meant a smaller radar signature, making it harder for enemies to see, lock, or shoot it down. The fuselage was built from aluminum-magnesium alloys, with steel reinforcement in high-stress areas for durability, without unnecessary weight. Its semi-monocoque structure gave it strength without excess mass, while the oval cross-section reduced drag at supersonic speeds. The jet was divided into 2 major sections: the forward section containing the cockpit, wings, fuel tanks, and landing gear, and the aft section housing the Tumansky engine, tail assembly, and exhaust nozzle. These linked at frame No. 28, allowing crews to remove the entire engine in hours instead of days. At the front sat the signature circular nose intake with its adjustable center cone, and below it the long pitot tube measuring airspeed, angle of attack, and yaw critical for supersonic flight. The MiG-21's wings are the feature that made it instantly recognizable and deadly in the hands of a skilled pilot. The aircraft used pure delta wings, swept back 33 degrees, ending in sharply cropped tips. This design wasn't meant for comfort or long-range cruising. It was built for supersonic efficiency, lightning-fast roll rates, and brutal hit-and-run attacks. Structurally, each wing revolved around a strong main spar, supported by 2 additional spars along the leading and trailing edges. This triple spar layout helped the MiG-21 withstand the intense aerodynamic forces of Mach 2 flight while keeping the overall weight low. Combined with the aircraft's short fuselage, the wings allowed the MiG-21 to snap into rapid rolls, change direction abruptly during dogfights, pull high angles of attack for surprise vertical maneuvers, recover energy quickly after aggressive turns. For a jet designed to ambush heavier Western fighters, these traits were priceless. Each wing carried 1 hardpoint, allowing the flight crew to mount missiles or small bombs. Inside, the wings were 2 fuel tanks, one ahead of the landing gear wells and one behind, feeding the engine and extending the aircraft's already limited range. The MiG-21's delta shape also helped delay stalling at high angles of attack, giving pilots the control they needed during close-range engagements or during rapid climbs to intercept incoming aircraft. Compact, simple, and brutally effective. The wings of the MiG-21 were a perfect match for the Soviet doctrine of speed, altitude, and surprise. The MiG-21's control surfaces were intentionally compact, but deceptively powerful, built to keep the jet responsive at Mach 2 while still giving pilots enough authority during tight dogfights. The aircraft relied primarily on its aileron system for roll control. These ailerons could deflect 20 degrees up or down, driven by actuator rods linked to a hydraulic booster system. If that hydraulic boost failed, pilots could switch to manual mode, still flyable, but significantly heavier on the controls. Between the ailerons and the wing roots were the main flaps, which extended to 24.5 degrees during takeoff and landing. In this configuration, the wings produced much more lift, allowing the MiG-21 to safely leave the runway at speeds as low as 211 miles per hour. Impressive for a supersonic interceptor. To stabilize airflow, especially at high angles of attack, engineers fitted 2 wing fences. These prevented the airflow from sliding outward across the wing and helped maintain predictable handling during hard maneuvers. At the tail section, the MiG-21 used a combination of a vertical fin with rudder, fully moving horizontal stabilators, a ventral fin below the fuselage. The all-moving stabilators were key to the jet's fast pitch response. They gave the aircraft superior climb rates and smoother handling at low speeds, allowing pilots to escape dangerous situations with rapid nose-up maneuvers. The entire control system was managed by an ARU 3 volts module, an automatic device that changed control stick forces depending on speed and altitude. At slower speeds, controls felt light and instinctive. At higher speeds or low altitude, the system intentionally made the controls heavier to prevent oversteering and structural overstress. The MiG-21 also carried 3 hydraulically driven air brakes, 2 on the lower sides of the fuselage and 1 positioned between the ventral fin and the fuselage pylon. When deployed, they allowed pilots to slow down sharply, especially useful in dogfights where overshooting a target meant losing the advantage. A circular drag chute, housed in a heat-shielded compartment near the ventral fin, provided rapid deceleration on landing and significantly shortened the runway distance required. Simple, rugged, and engineered for split-second reactions, the MiG-21's control surfaces perfectly matched the Soviet doctrine of speed, agility, and lethal first strike capability. End of control surfaces section. At the heart of the MiG-21F-13 was the Tumansky R-11F-300, a compact but brutally efficient power plant that turned the lightweight Soviet fighter into a Mach 2 interceptor. The MiG-21F-13 could reach a top speed of 1,351 miles per hour at 42,650 feet around Mach 2.05. Even at sea level, it could still push to 745 miles per hour, an extraordinary performance for a jet designed in the 1,950 seconds. This power came from a twin-axial turbojet engine, built around a configuration consisting of a 6-stage compressor, 10 independent flame tubes inside the combustion chamber, a 2-stage turbine, a dedicated afterburner chamber, a hydraulically controlled variable exhaust nozzle. The engine measured just over 15 feet long, a little more than 2.5 feet in diameter, and weighed 2,606 pounds, extremely compact for its thrust class. At full military power, no afterburner, the R-11F-300 produced 8,598 lbf of thrust, while spinning at 11,150 revolutions per minute. For a fighter that weighed just 12,882 pounds empty, that power-to-weight ratio gave the MiG-21 exceptional acceleration and climb performance. The layout of the engine was designed for modular maintenance. The afterburner, turbine, and compressor could be removed in sections, making it easier to service in the field. The entire rear fuselage was even built around a separation point frame No. 28, allowing ground crews to detach the tail and slide the engine out for repairs. The MiG-21's narrow fuselage and circular nose intake were shaped specifically to optimize airflow to the R-11, especially at high speeds. Its unique intake cone, one of the aircraft's visual trademarks, worked in unison with the engine to manage high-pressure shockwaves and keep the jet stable during supersonic flight. Lightweight, simple, and remarkably durable, the R-11F-300 didn't just power the MiG-21, it defined the aircraft's identity as a fast, lean interceptor built for sudden, decisive strikes. If the Tumansky R-11F-300 was the heart of the MiG-21F-13, then its afterburner was the adrenaline shot that transformed the aircraft from fast to ferocious. Mounted directly behind the turbine section, The Afterburner used a ring of radially arranged fuel injectors that sprayed fuel straight into the jet's exhaust stream. When this fuel met the superheated gases leaving the turbines, it ignited instantly, creating a massive surge of thrust. This system boosted the MiG-21 F-13's performance dramatically. 10,803 lbf of thrust at minimum afterburner, 12,677 lbf at maximum, nearly 50% more thrust than the engine's standard output. For a fighter as lightweight as the MiG-21 F-13, that kind of thrust meant explosive acceleration, especially in the vertical climb. It allowed pilots to snap the aircraft into steep intercept angles, regain lost energy during dogfights, and punch through the sound barrier with authority. But this power came with a price. The Afterburner was extremely fuel-hungry. At low altitude, using full afterburner could drain the aircraft's fuel supply in under 20 minutes. For that reason, pilots only used it when absolutely necessary takeoff, combat merges, evasive maneuvers, and high-speed intercepts. Still, when engaged, the Afterburner was unmistakable. A long, bright plume of raw fire trailing from the exhaust, propelling the MiG-21 forward with brute Soviet simplicity. It was one of the key reasons the aircraft could climb rapidly, turn hard, and recover energy fast, giving MiG-21 pilots a decisive edge in short, violent engagements. The MiG-21 F-13's fuel system was compact, efficient, and brutally simple, because it had to be. A lightweight airframe built for speed left very little internal space for fuel, and that limitation shaped how the aircraft fought. Inside the fuselage were 7 internal fuel tanks, supported by 4 additional wing tanks, giving the MiG-21 F-13 a total internal capacity of 652 US gallons. This was only a fraction, roughly 1/5 of what the American F-4 Phantom II could carry with its massive 3,335-gallon capacity. As a result, the MiG-21's flight endurance was limited. Depending on altitude and throttle settings, a typical mission lasted 45 minutes to an hour. But if the pilot used afterburner at low level, those tanks could be emptied in less than 20 minutes. To extend its range, the aircraft could mount an external drop tank on its central fuselage pylon. This tank allowed the MiG-21 to reach interception zones or remain on patrol longer before engaging targets, but it was jettisoned immediately once combat began. A crucial part of the fuel system was the air intake design, which directly impacted engine performance. The MiG-21's signature circular intake used a hydraulically adjustable shock cone with 3 positions. Fully retracted, speeds up to Mach 1.5. Mid-position, Mach 1.5 to 1.9. Fully extended, above Mach 1.9. This cone regulated the airflow entering the engine, preventing compressor stall at high speeds and keeping thrust stable during transonic and supersonic flight. The aircraft also carried 3 auxiliary air intakes designed to prevent engine stalls in high-angle maneuvers, provide extra airflow during takeoff for added thrust, and cool the rear fuselage during intense engine operation. At the rear, an automatically adjusting exhaust nozzle controlled the flow of exhaust gases to optimize thrust and fuel efficiency, fully open at idle, tightest at roughly 65–68% RPM, reopens when the afterburner engages. If the automatic system failed, the pilot could switch to manual control, though only with 2 settings, fully closed or fully open. Together, these systems allowed the MiG-21 to squeeze as much performance as possible out of its limited fuel load, enabling blistering acceleration and rapid intercepts, at the cost of very short endurance. No narration visual end card for the segment. For all its speed and agility, the MiG-21 F-13 wasn't built to carry a wide array of weapons. Its armament package was minimalist, but deadly when used with the right tactics. The core of the weapon system centered around 3 components. 1. The SRD-5MK rangefinder. The MiG-21 F-13 did not have a modern radar. Instead, it used the SRD-5MK range-only radar, embedded in the nose intake. It couldn't search, track, or scan. It only measured distance to a target directly in front of the aircraft. There was no separate radar display in the cockpit. The SRD-5MK fed its data directly into the ASP-5ND optical gun sight, which calculated firing solutions for both the cannon and the missiles. It was simple, light, and brutally Soviet in its design philosophy. If it doesn't help the aircraft climb, run, or shoot, it doesn't belong on board. 2. NR-30 cannon. The MiG-21 F-13 carried a single NR-30 30mm cannon, mounted on the lower right side of the fuselage. Rate of fire, 900 rounds per minute. Total ammunition, 60 rounds. Typical load, only 30 rounds. The limited ammunition reflected reality. MiG-21 pilots rarely used the cannon in combat. Most kills came from missiles, and every kilogram mattered when chasing Mach 2 performance. Still, the NR-30 was devastating at close range, capable of shredding a target with just a couple of hits. 3. K-13 AR-3. The F-13 variant was the first MiG-21 to carry guided missiles. 2 K-13 AR-3S, infrared homing missiles, NATO codename AA-2 Atoll. This missile was a Soviet reverse-engineered copy of the American AIM-9B Sidewinder. It wasn't as sensitive or as reliable, but it was light, simple, and easy to maintain. Specifications: warhead, 25 pounds HE fragmentation, range, 0.6, 4.7 miles. Guidance, rear aspect, infrared seeker. Tactical use, fire from behind, close range, high closing speed. The major weakness was the seeker's poor infrared sensitivity, which meant the missile often struggled to lock onto cooler or maneuvering targets. But when used in coordinated ambush attacks, the way the MiG-21 doctrine intended, the Atoll could be brutally effective. Together, the MiG-21 F-13's weapon systems weren't designed for prolonged dogfights. They were built for one thing: hit fast, fire once, disappear. This was the foundation of the MiG-21's success across Vietnam, the Middle East, and dozens of Cold War air battles. The cockpit of the MiG-21 F-13 was built around a single idea: simplicity that keeps the pilot focused on flying fast and killing quickly. Compared to Western fighters of the same era, the MiG-21 F-13's cockpit looked almost bare. No advanced radar displays, no layered avionics, no digital clutter, but every gauge and switch served a clear purpose in the brutal, minimalist design philosophy of Soviet engineering. Layout and instruments. The instrument panel was tall, deep, and packed tightly with analog indicators, including artificial horizon, altimeter, Mach, airspeed gauge, fuel quantity indicator, engine RPM gauge. Warning, status lights. Every instrument was arranged vertically to fit inside the narrow fuselage, forcing pilots to learn the layout by muscle memory. To Western pilots, this looked cramped. To Soviet pilots, it was efficient and fast. Cockpit color and ergonomics. Unlike later MiG-21 variants painted in turquoise to reduce fatigue, the F-13 cockpit was finished in shades of gray, a Spartan environment for a pilot who needed focus more than comfort. Switch panels lined both sides of the cockpit. Some were easy to reach, others deliberately tucked away, requiring long training hours to master. The MiG-21 F-13 rewarded discipline and punished hesitation. Controls. The throttle sat on the left side, along with critical flight and engine controls. The control stick, centered between the pilot's legs, integrated the cannon trigger, missile launch button, trim controls, dampers, and a brake lever. This stick wasn't designed for comfort. It was designed for combat. ASP-5ND. Gun sight. For aiming, the pilot used the ASP-5ND optical computing gun sight, a gyro-stabilized system that automatically calculated lead and projected cues onto a glass plate acting as a primitive HUD. Modes included gyro mode, for dynamic target tracking, fixed mode, for simpler aiming scenarios. This entire system worked hand-in-hand with the SRD-5MK rangefinder, giving the pilot a firing solution without modern radar. Canopy and armor. The cockpit was pressurized and capped, with a forward-opening bubble canopy built from two thick layers. 0.4-inch convex acrylic heat-resistant glass, 0.57-inch flat silicate triplex front pane. The fixed armored windscreen beneath the canopy measured 2.44 inches in thickness, heavy, but essential for high-speed combat. The entire canopy weighed about 126 pounds, but its most remarkable feature was its role during ejection system. During an emergency, the canopy didn't separate from the aircraft in the usual way. Instead, it latched directly onto the ejection seat, forming a protective capsule that shielded the pilot from the violent airflow during high-speed ejection. Either of the seat handles could trigger the ejection, an important redundancy in a jet built for sudden, violent engagements. Startup procedure. Before the engine even started, the pilot had to run through an extensive checklist. Cockpit switches, electrical systems, pneumatic systems, hydraulic pressure, fuel valves and pumps, free movement of control surfaces. Only after confirming all these systems did the pilot fire up the R-11 engine and prepare the aircraft for flight. Launching the MiG-21 F-13 into the air was not a casual process. It was a sequence of precise actions that demanded discipline, timing, and confidence. After completing the long pre-flight checklist inside the cockpit, the pilot brought the Tumansky R-11 engine to life by moving the throttle from stop to idle and pressing the starter for 2 to 3 seconds. Once the engine stabilized, the pilot confirmed all core systems were behaving correctly: electrical, hydraulic, pneumatic, and fuel, before signaling the ground crew to disconnect external power. With the canopy locked, flaps tested, air brakes checked, and the G-suit verified, the MiG-21 was cleared to taxi. Acceleration. On the runway, the pilot pushed the throttle fully forward and released the brakes, holding the control stick centered. The aircraft accelerated rapidly, its delta wing design generating lift later in the roll compared to conventional wings. At 124 miles per hour, the pilot pulled the stick back roughly 2/3 of the way, raising the nose to about 9 degrees. The MiG-21 lifted off the ground once airspeed reached 220 miles per hour, transitioning smoothly into its climb. Initial climb. Under normal conditions, the aircraft climbed at 430 miles per hour indicated, gradually building up to a true airspeed exceeding 580 miles per hour. But in intercept scenarios, MiG-21 pilots pushed the aircraft much harder. By accelerating to 620 miles per hour immediately after takeoff, the MiG-21 F-13 could rocket to 33,000 feet in only a few minutes. This rapid climb rate was one of its most significant advantages during the Cold War, enabling it to reach intruding aircraft or incoming bombers before they got close to their targets. Breaking the sound barrier. If the pilot needed to go supersonic, the afterburner was engaged. As the aircraft accelerated through Mach 0.8 to Mach 1.2, the nose intake cone automatically shifted positions to manage shock waves and keep airflow into the compressor stable. This small cone was the key that let the MiG-21 slice cleanly through the sound barrier. High-altitude flight. Once the aircraft reached around Mach 1.8, the pilot would initiate a climb to 59,000 feet, using the aircraft's power-to-weight advantage to rise steeply without losing energy. Takeoff in the MiG-21 F-13 was not merely a departure, it was the opening move in a tactical sequence. Whether the pilot was scrambling to intercept an intruder, heading to training, or entering combat, the MiG-21's takeoff profile was always about one thing: getting to altitude fast enough to control the next engagement. The MiG-21 F-13 wasn't designed to be a brawler. It was built to be a hit-and-run predator, fast, sharp, and lethal in the hands of a skilled pilot. With a service ceiling of 62,335 feet, the MiG-21 could climb above most opponents, strike, and escape before they had time to react. And the first battlefield where this philosophy was tested brutally was Vietnam. First engagements. The MiG-21 F-13 entered combat in North Vietnam on the 6th of March 1966, facing American aircraft flying Operation Rolling Thunder missions. Initially, North Vietnamese pilots attempted traditional dogfighting, the same tactics they used in the older MiG-17. They quickly realized something. The MiG-21 wasn't built for swirling horizontal fights. Its strengths were speed, climb, and surprise, so pilots adapted. The ambush tactic. What emerged became one of the most famous air combat methods of the Cold War. The ambush tactic. It worked like this. Two MiG-21 seconds approached U.S. formations head-on, acting as bait. Enemy fighters, usually F-4 Phantoms, gave chase. A third MiG-21, flying 2-3 miles behind and below, accelerated hard and climbed rapidly. As the 4 seconds focused on the first pair, the trailing MiG-21 rose onto their tail. The moment the gun sight locked, the pilot fired an atoll missile and disengaged immediately. This tactic exploited two key advantages. The MiG-21's small frontal profile, which made it extremely difficult to detect visually or on radar. The F-4's radar, mounted in the nose, which struggled to pick up a small jet approaching from behind. Pilot testimony. American pilots who fought against the MiG-21 inches Vietnam acknowledged its strengths. U.S. Air Force Captain Frederick S. Olmsted Jr. famously said, "They were very fast, very nimble, and a very capable adversary. If you weren't careful, the MiG-21 could turn the tables on you very quickly." Strategic impact. The MiG-21's effectiveness forced the United States to overhaul its air combat doctrine. It was one of the reasons the U.S. Navy created the Top Gun program, and why the Air Force adopted new training that emphasized maneuvering skills and energy fighting. The MiG-21 F-13 proved that even a simple, lightweight interceptor, when paired with smart tactics, could threaten far more advanced Western aircraft. It became a symbol of asymmetric air combat. Used speed, altitude, and surprise knot sensors and long-range missiles. Bringing the MiG-21 F-13 back to the ground required as much discipline as launching it into the sky. With its high landing speed, narrow undercarriage, and delta-wing aerodynamics, the aircraft demanded precision during every second of the descent. Initial approach. To prepare for landing, the pilot first descended to 1,640 feet and reduced speed to about 280 miles per hour. Only then could the landing gear be safely lowered. At this stage, the MiG-21 behaved like a dart it wanted to keep flying fast. The delta wing produced excellent lift at high speeds, but lost lift rapidly once the aircraft slowed down, meaning the pilot had no room for sloppy control inputs. Final approach and flare. As the aircraft neared the runway threshold, the pilot executed a flare. The nose was raised to around 10 degrees, reducing the descent rate, but cutting off nearly all forward visibility. With the nose pitched upward, the pilot had to judge altitude by looking sideways, one of the MiG-21's signature quirks that made landings notoriously difficult for inexperienced pilots. At touchdown, the aircraft slowed to 160-170 miles per hour, still significantly faster than many Western fighters of the era. Deceleration. Once on the ground, the pilot applied gentle braking pressure to prevent the wheels from locking. To shorten the landing roll, he could deploy the aircraft's drag chute, located in a heat-shielded compartment ahead of the ventral fin. This braking parachute dramatically reduced stopping distance, an essential feature for operations on shorter Soviet airfields. Taxi and shutdown. When the aircraft had slowed enough, the pilot released the nose wheel brake, allowing sharper turns during taxi. Once back in position, the engine was shut down by pulling the throttle back to the stop position. Even on the ground, the MiG-21 demanded discipline. Landing it wasn't just about flying, it was about understanding the aircraft's aerodynamic limits, its quirks, and its unforgiving stall behavior. A mistake in the final moments could be as dangerous as any dogfight. When it first entered service, the MiG-21 represented the cutting edge of Soviet fighter aviation, simple, fast, brutally efficient, and fully capable of standing toe-to-toe with Western jets of its era. But like all machines built around a narrow design philosophy, its strengths eventually became its limitations. Its small airframe left little room for more advanced radars. Its limited fuel supply capped its range, and its compact size restricted both payload and upgrade potential. Yet despite these constraints, the MiG-21 became one of the most successful jet fighters ever built. It was inexpensive to maintain, straightforward to operate, and rugged enough for air forces with limited resources. And with the right tactics, especially the hit-and-run ambush strategies perfected in Vietnam, it proved that raw speed, acceleration, and pilot skill could outweigh pure technological superiority. Beyond Vietnam, the MiG-21 carved out a global legacy. It appeared in conflicts across the Middle East, India and Pakistan, Africa, Europe, and even played a part during the Cuban Missile Crisis. For decades, it served as the backbone of dozens of air forces, adapting to new missions long after more advanced fighters replaced it in major powers. The MiG-21 is more than a Cold War artifact. It is a reminder that effective engineering does not always come from complexity. Sometimes, the most influential aircraft are the ones built on clarity of purpose. Climb fast, strike hard, and survive. If you're curious about another radical piece of aviation history, the futuristic Nazi jet fighter known as the Horten Ho 229, you can watch that film next. Thank you for watching. Breaking down a machine as iconic as the MiG-21 is always a challenge, and even then, some details inevitably remain in the shadows. If you spot any errors or have insights to add, let us know in the comments.